Hey everyone, and welcome to The Explainer. Today, we are getting our hands dirty decoding the actual digital DNA that powers modern manufacturing. We're unpacking a really fascinating open-source GitHub repository titled Hari656 Bytes/Industrial Automation. It's just an incredible collection of practical, real-world PLC programming projects built for industrial machines, focusing specifically on motor control, protection, sequencing, and migration logic. And we are going to break down exactly how it all works.
There's a question that sits right at the very heart of modern engineering. How exactly do we bridge the gap between lines of software code and massive, heavy-duty industrial machines? Well, today's explainer takes what looks like a static list of repository files and translates them into a dynamic roadmap for mastering industrial control systems. We're going to see exactly how digital logic makes physical metal move.
Okay, let's dive into this. We'll start with the brains of automation, move on to mastering basic motor control, check out sequencing and motor protection, touch on counting and migration logic, and finally, look at the future of factory floors. We're going to build this up from the most basic components right through to complex, automated systems.
Section 1. The brains of automation. Before we look at the code itself, let's set the stage with the core tools.
So, our primary software environment here is Delta WPL Soft, which is used to write what's known as ladder logic. And I love this. Ladder logic actually looks just like electrical circuit diagrams because it was originally designed to mimic the physical wiring of old mechanical relay cabinets. Now, just to be completely clear and impartial, Delta WPL Soft is simply the specific software tool chosen for this particular open source repository. There are plenty of brands out there, but this environment gives us a perfect practical lens to understand how ladder logic commands hardware.
Now, what's really interesting about this slide is the physical hardware required. We aren't just talking about abstract code floating around in the cloud somewhere. This repository bridges the digital and the physical. The code written in WPL Soft is deployed onto a physical Delta PLC, a programmable logic controller. And that controller ultimately fires physical contactors, snaps relays shut, triggers timers, and ticks counters. It's this digital logic commanding the actual physical forces on the factory floor.
Section 2. Mastering basic motor control. If the PLC is the brain, while the motors are the fundamental muscles of the factory.
The source material maps out three key practical projects here. Foundational motor start-stop logic, the star-delta motor setup for startup current reduction, and sequential motor operations. So, let's break these down and give you a clear map of the motor control logic we're about to explore.
We kick things off with the Motor Start-Stop project. It's a basic application using PLC ladder logic to control industrial motors. Sure, it sounds simple, but this is literally the foundational building block of absolutely all factory automation. Before you can build a massive assembly line, you need flawless, fail-safe logic simply to start a motor, and honestly, just as importantly, to stop it safely. And this brilliantly illustrates our next progression, the star-delta motor starter. Large industrial motors draw a massive surge of power when they first spin up. So this project uses a really clever three-step logic. First, it starts the motor in a star electrical connection to artificially reduce the current. Second, a PLC timer counts down as the motor gains momentum. Third, the logic switches the circuit over to a delta connection, delivering full power. It's an elegant piece of code designed entirely to protect your equipment from massive power surges during startup.
Section 3. Sequencing and motor protection. Because once we can start a motor, we need to protect it and coordinate it with the others.
Let's explore the sequential motor control project. Think of progressive stacking here. This project builds directly on that basic start-stop logic we just looked at, but now it choreographs a multi-step factory floor process. Just imagine a conveyor belt that absolutely cannot start until the shredder ahead of it is spinning at full speed. This ladder logic ensures multiple motors operate exactly according to that rigid, predefined sequence.
But with multiple motors comes multiple points of failure. So the repository includes multi-motor protection files, and these are absolutely essential. This is PLC-based control logic dedicated entirely to protecting and managing those motors simultaneously. It really emphasizes how crucial this logic is for preventing cascading hardware failures in a real-world facility. If one motor jams, this logic tells the PLC to instantly shut down the upstream motors so material doesn't just keep piling up and destroy the whole line.
In a similar vein, the motor cooling project is a perfect example of automated safety. Heavy machinery generates incredible amounts of heat, right? This specific ladder logic monitors conditions and controls the cooling operations, ensuring the motors don't overheat and burn out. It's essentially an invisible shield of code protecting million-dollar machinery.
Section 4. Counting and migration logic. Now we're shifting gears from just moving parts to tracking production and managing the software itself.
Next up is the Production Parts CNT or Count project. Picture a real-world scenario of freshly manufactured boxes moving swiftly down a conveyor belt. This logic uses PLC counters to perfectly tally those boxes every single time they break a sensor beam. It ensures accurate inventory and production tracking right at the machine level, with zero human intervention required.
Now, the repository isn't just about active logic, it's also about legacy management. There's a specific markdown file dedicated to WPL soft conversion and compatibility. This is incredibly important for engineers out in the field. When they are tasked with migrating or upgrading older legacy factory systems to new hardware, documentation like this ensures the old ladder logic can be safely translated and executed on modern controllers without breaking the factory line. So the crucial point is the educational core of this repository. By studying these files, you walk away with practical knowledge of PLC ladder logic, interlocking, timers, counters, and real industrial control logic. These aren't just static files. They are practical learning references meant to be pulled apart and studied.
Section 5. Future of Factory Floors. Let's look at where this open-source repository is heading next.
The source material lists some incredibly exciting upcoming additions. We're talking variable frequency drive, or VFD control, for precise speed management, human-machine interface, HMI integration for touchscreen controls, Modbus communication for networking, and most notably, industrial IoT integration. These upcoming projects are going to completely elevate those basic motor controls we just discussed into a fully modernized, interconnected, and smart system.
I actually want to read this quote directly from the repository's About section because it hits the nail on the head. A collection of industrial automation projects, tools, and learning resources covering PLC programming, VFD control, HMI, sensors, electrical control systems, and automation technologies. That sentence really encapsulates the massive scope and ambition of this project. It's basically an entire curriculum laid out in code. Which leaves us with this final provocative thought. How will you apply these building blocks to your own automation challenges? Whether you are a seasoned engineer looking for a template or a student trying to understand exactly how the physical world is programmed, the logic is all there waiting for you. Dive into the source material, experiment with the ladder logic, and start building your own solutions. Thank you so much for joining me for this explainer, and keep